All right, thank you everyone. Thanks for being here. It's so nice to see such a big crowd and so many interested in progressive web apps. So my name is Jonas and I'm a front-end dev here at Algolia. I work mostly on the front-end part of the website. I worked on the documentation, the static websites, everything related to Algolia front-end. And so, I don't know if you heard, we raised a very big Series B, and with that we needed to rebuild our entire website. We needed to make it new, nice, make it a Series B company website. And along with that, we decided to focus some aspects on it on performance. We decided to improve how it loads. We decided to add a PWA features, basically. Because at Algolia, the speed really matters. When we talk about speed of our search engine is able to deliver millisecond results, keystroke results. So we need to make sure that we can do the same to be able to talk about speed and say that it really matters. So this is what we started with. This was the old website. As you can see, the progressive web app was very bad. We had a poor performance. Accessibility was kind of there, but it worked. And we had kind of best practices. Also, this is a result of Lighthouse plugin used on Chrome, and it's about 2 months old result. As you know, Lighthouse is constantly being developed, so maybe not really relevant, but it's here to give you an idea of what we had before. So PWAs to save the day. I'm going to give you some examples of what we did, some tips and tricks that really improved us. Hit the load time, the service worker, the caching strategies that we used to improve the user experience and to get that load really fast. So Ilya Grigorik, the kind of god of web performance, once said that no bit is faster than the one that is not sent. So first thing you do is you send fewer bits. What that meant for us at the start was remove most of our dependencies. We removed jQuery, Lodash, all of the stuff that we didn't really need. All of that went out. We were able to reduce JavaScript sizes from 120 kilobytes to 20 kilobytes, 30 kilobytes, massive. The second thing meant we needed to remove some of our CSS dependencies, something that we didn't really use. We made an approach of how to build CSS, which allowed us to build declarative HTML, move really fast. So now we can build websites way faster than we used to do it before without bloating the code. We have our kind of internal bootstrap for that, and it's okay. Works very nice. So first thing we did as a PWA feature, we enabled WebP, image compression. So for us, we use Cloudflare as our service. So that was really simple. Cloudflare gives you an option. You basically just have to click a button to enable WebP. And what this did first was it provided a compression of about 30%. So this means we went from about 30 kilobytes to 20 kilobytes on average. And what's the good thing about Cloudflare is that they do the compression on the fly, which means that if an asset is, if you have a WebP that's bigger than, in the end, than a JPEG, they're going to serve the JPEG. They do this using a content disposition header. So it means you request. You don't have to make another WebP image. You don't have to basically complicate your build step. All you do is you enable WebP. They do the compression on the fly, cache it, and return it if the browser accepts the WebP header. But if you're doing it on your own, you're probably going to have to configure Nginx. You're going to have to include something into your build process. You're going to have to maybe configure Apache. I don't know, whatever you use. So Ilya Grigory has a detection for that. It's super simple. If you have it, please do use it. It's a small script, either Nginx or Apache, and you'll have WebP support. After that, just make sure to include WebP image generation into your build process. There are a few libraries to do that. You should be fine. So that saves us a lot of things. The next thing was we had our load time was super slow. It was about 6 seconds. It went from 0 to 6 seconds. It was a terrible experience, and that was on a good connection. Our website was it's really big at the time. So to give you an idea, at the start it was about 1 meg. We managed to put it down to 400 kilobytes. 200 kilobytes of that is marketing things that we kind of need, track the users. To give you an idea, half of that is now the website. But now we at least have the budget performance for it. We have the budget to include that on the website. Before we didn't really have it. So we decided to fake speed, as you would say, progressively load the website. We don't need everything, so you load the small parts first, and then you load the entire thing. Takes roughly the same, but the user experience is way better. You try to provide users with a good feedback at like, if you can do it second, millisecond time. I mean, millisecond, yeah, if it's a cached resource, probably. So first thing we did was that, and first, this is how our header looked like. This was what was in our header tag. So I'm going to give a trick question. How many requests does this make? So who wants to answer? How many requests? Okay, to give you an idea, that's 11 requests. So you want to know why? First thing is every font is first going to request the font, and then it's going to request the 3 TTF, the whatever fonts you need. So you're going to go through 11 requests for that. Then you're going to have to load the CSS files that you don't really need. The only one we need right now is the application CSS. That's the whole CSS we use. It's about 50 kilobytes, and inside it is the entire website. It's everything we have. So that means all of the pages. So what we do, I'll show you later, is we cache that. But now I'm going to show you something a bit about slow fonts. And it was a bottleneck that we didn't really know about. But if you see this, a lot of you probably use fonts hosted on Google Fonts or whatever kind of thing. You might need an external service. If you use HTTP2, that means you cannot reuse a connection. You have to go every time. You have to go through the DNS resolution. You have to establish a connection, and you have to do the SSL negotiation before you can fetch the font, before you can fetch any resource, actually. So for us, just self-hosting that font improved time to load by 1 second on a 3G connection. That's huge. It's just one font. Nothing changes. Next thing is the power of HTTP2. As you know, HTTP2 comes with multiplexing connections and a HTTP server push, which means that the browser doesn't have to load the entire HTML file. It doesn't have to parse it and then establish the priority list of loading the resources. We can just say, OK, you want the index. This is what you also need along with the index. You're going to need the CSS for this. You're going to need the JavaScript for that. What that means is as the browser will start receiving the HTML file, you will also start receiving all of the other requests that it will need. In our case, that's the application CSS file, the only render blocking assets that we have right now, which means it's going to receive it faster than it would if it had to parse the entire HTML. As you can see here, the web page test, it actually shows you if the asset was server pushed. So you'll be able to check if your link headers work, and it's a pretty useful tool as well, web page test, so use it. So after we did all these changes, it was time to measure again. So this is the time to interactive we had before we did the updates. So about, I guess, 50% of the traffic was getting a kind of good experience. But you have to know that most of the traffic was probably coming from this office on a gigabit connection. So that thing could be subjective. After that, we saw the improve go to about 22% from 0 to 0. So roughly 86% of the traffic was getting the optimal experience, which is pretty nice. It's pretty good for us, as speed is really a core feature for us. So last thing that we needed to do is time to say goodbye to the dyno. We had no offline support yet. We're not using the service workers. We're not caching anything except the browser cache. So for that, if you want to do it today, there are two libraries. One is SW Toolbox and one is SW Precache. If you use SW Toolbox, it's going to give you an option to dynamically cache resources, whereas the SW Precache is you're going to have to predefine the resources that you want to cache. It's more useful for things like application shell models, stuff like that, stuff that's not going to change, that's going to be there, and that you want to have it at the first render. Whereas SW Toolbox is basically going to be there. And the way it works is you specify a regex, you specify a string. If it matches that, you provide a network strategy, and that's how you load. So in this case, you can see that how we handle the CSS caching. So you have the router, and you say, okay, it's a GET request. It's a CSS. We use the CSS pattern, which is anything that's on algolia.com, and it ends with 8-bit kind of hash, which is a SHA-1 of the middleman build tool that we use. You cache all of that. We said, okay. That's everything we're caching. You specify the cache name and you specify the network caching strategy. In our case, this is network fastest because we want to serve. So there are actually a few network strategies that you can use. We decided to go with network fastest, which basically it makes a race condition, basically the one that resolves first. Either it's the cache or it's the network. Obviously, that's always going to be the cache most of the time, but it's always going to fetch it from the network. And when it does fetch, it's going to update it in the cache, just in case you might have changed something or whatever you need to update, because you don't want to be stuck on the front end having cache and you cannot update the resource. So after you're done, you can validate the cache. You'll see that actually it's coming from a service worker. It's being served to the user in 7 milliseconds. So that's basically how long it takes them to see the website. You click and it's there. If the browser supports the service worker, otherwise you're going to have to fetch the request again. After that, just specify a manifest.json, which is kind of the way you want your website to look on the devices. So if you're looking at a mobile device, when you add it to the home screen, that's what the stuff you configure. You configure the name, you configure the theme colors, the background colors, and you configure the icon, which is the splash screen. And that was basically it. Once we run it through a final audit, right now, this was done this morning, we can see that we have 100 out of 100 in a progressive web app score. So that's it. Thank you very much. Oh yeah, so if anyone has questions. Yes.
Hi, thank you first.
Yes.
I saw that you use the manifest JSON.
Yes.
How is it useful for the user to install the Algolia app on their mobile phone?
So it's not really used, but it's a requirement for the PWA.
It's just for the 100%, right?
Yes.
Okay.
Yeah. That was like if we do it, and so if you do install our website on your phone, you're going to get a nice splash screen. But that's basically it. That's why we have it.
Okay. Thanks.
All right. Thank you very much. Yeah,